Question number 9. 3 points PQR have coordinate this, this, and this, where K is the constant. It is given that the angle of PRQ is right angle. So angle of PRQ is 90 degree. So show that one of the possible value of K is 10. Find the other possible value. Okay, if this one is P, angle of PRQ, this one is 90. So this one is R and this one is Q. And we have been given coordinates of P, which is negative 13 and 5. Coordinate of R, which is given, is 2 comma K, and coordinate of Q is R comma 1. So there are two approaches. We can use this method also to find the value of K. PQ square is equal to PR square plus PRQ square. We can use this equation to find the value of K, or second method is we can use the slope. We know that normal slopes are satisfy m1 time m2 is equal to negative 1. In this case, these two lines PR and PQ are normal to each other. So this one is m1 and this one is m2, or you can say that this one is m1 and this one is m2. So slope of m1 is y2 minus y1 over x2 minus x1. So k minus 5 over 2 minus 13 times m2. Slope of m2 is 1 minus k over 5 minus 2, because y2 minus y1 over x2 minus x1 is equal to negative 1. When we solve it, we will get k minus 5 over 2 plus 13 is 15 times 1 minus k over 5 minus 2 is 3 is equal to negative 1, and when we solve it, it will be k minus 5 times 1 minus k times equals to the 15 times 3 is equals to the 45, so negative 45. Solve it further, you will get k minus k square minus 5 plus 5k equals to negative 45. Okay, when we solve it further, it will be k square negative positive k square plus 6k minus 5 plus 45 equal to 0. Okay, when we solve it, negative k square plus 6k plus 40 equal to 0, and this is the quadratic equation, which is k square minus 6k minus 40 equal to 0. This is the quadratic equation, so we can use quadratic formula or the factorization. So negative 40 times 1 is negative 40, or we can use negative 10 times 4 is also 40, and when we add negative 10 and 4, we will get 6k square minus 10k plus 4k minus 40 equal to 0, and when we take common, k minus 10 plus 4 k minus 10 equal to 0. Okay, when we take k minus 10 common from these two terms, we will have k minus 10 and k plus 4 equal to 0. We have two factor equating with 0, so k minus 10 equal to 0. On the other side, k plus 4 equal to 0, and in this case k is equal to 10, and in this case k equals to negative 4. So one of the possible values k is 10, the other possible value is
negative 4.
Part B. It is now given that k is equal to 10. A circle passes through the point PQR. Find the equation of the tangent to the circle at R, given your answer in the form of ax plus by plus c equals to 0, where a, b, c are integers. So we are given a circle, okay, and this circle is passing through the point P, and this one is P, this one is R, and this one is Q. And points are negative 13, 5, 5, 1, 2K, negative 13, 5, 2, comma K. K is 10, which is given. This is the circle which is passes through the all 3 points of the right angle triangle. And we need to find the equation of the tangent to the circle at R. So this is the tangent to the circle at R. So we need to find the equation of this tangent. So we know that to find the equation to the tangent, we need two things. Equation of tangent required, equation of tangent required point, which is R, and this one is 2 comma 10, and we need the slope of the tangent. In this case, we have the point and we need to find the tangent. One concept you need to know, that if circle passes through all points of right angle triangle, then the diameter of circle is equals to the hypotenuse of the triangle. This is the concept you should know. So this PQ is the diameter, and the midpoint of the PQ is center, and center is O, we can say. So first we calculate the center, which is O. Center is mid of the PQ, mid of PQ, which is equals to the sum of the x coordinate, which is 5 plus negative 13 over 2, comma sum of the y coordinate divided by 2. So 5 plus 1 over 2, and this one is equals to the negative 8 over 2 and 6 over 2. So center is negative 4 comma 3. Why we need center? When we draw the line from R to center, so you will have a normal angle between tangent to the R to the OR. So if we can find the slope of the OR, we can easily find the slope of the tangent to the circle at R. So first we find slope of the OR, which is M, and this one is equals to the y2 minus y1. So here another point is R, which is 2 comma 10. So slope is y2 minus y1, which is 10 minus 3 over x2 minus x1, which is 2 minus negative 4, and this one is equals to 7 over 6. So this is the slope of OR, and we can find the slope of tangent to the circle at R. Slope of tangent MT and this one is M. These two lines are perpendicular to each other, so we can say that mt time M is equals to -1 and M is which is 7 over 6. So this one is equals to mt, which is slope of the tangent, times 77 over 6 is equals to -1, and slope of the tangent is -6 over 7. So this is the slope of the tangent and we have the point R, so we can use slope point form. Using slope point form. So slope point form is y minus y1 is equals to mt slope of the tangent time x minus x1. In this case, point is R, which is 2 comma 10, and this one is x1 and this one is y1. So we can plug slope value and the point value in this equation. We will have, so y minus y1, which is 10, is equal to mt, which is -6 over 7, time x minus x1, which is 2. So when we solve it, we will have y minus 10 times 7 after cross multiplication and -6 times x minus 2, and this one is equal to the 7y minus 70 and equals to -6x plus 12, and this one is equal to the 7y plus 6x minus 70 minus 12 equal to 0, and 7y plus 6x minus 82 equal to 0. So this is the required equation of the tangent to the circle at R.